Physics Class 11. After this video, you will be knowing the fundamental forces in nature. So firstly, let's know what are fundamental forces in nature. We know that physics is the study of nature and natural phenomena. It deals with certain basic laws which govern the natural world. We shall now discuss the nature of fundamental forces and the nature of laws that govern diverse phenomena of physical world. We know that force is an effort in the form of push or pull required to move a body or stop a moving body or deform or break the body. In the microscopic world, we come across gravitational forces, muscular forces, tension in springs, ropes, forces of friction, forces due to pressure, etc. In addition, there are forces between charged particles and magnetic bodies. Physics has revealed that all the forces occurring in different contexts arise from a small number of fundamental forces of nature. Though the origin of derived forces is complex, yet they can be understood in terms of the four fundamental forces. These four fundamental forces govern the macroscopic as well as microscopic world. The four fundamental forces are gravitational forces, weak nuclear forces, electromagnetic forces, and strong nuclear forces. Firstly, let's discuss about gravitational forces. The gravitational force is the force of mutual attraction between any two objects by virtue of their masses. As every object has some mass, therefore, gravitational forces are universal forces. That is, every object in this universe attracts every other object at all distances. For example, all objects on Earth experience the force of gravity due to the Earth. In fact, all large-scale phenomena of the universe, such as formation and evolution of stars, galaxies, and galactic clusters, are explained in terms of gravitational forces. The magnitude of the force exerted by a particle of mass m1 on another particle of mass m2 at a distance r from it is given by Newton's law of gravitation, which says that F equals g m1 m2 divided by r square, where g is the universal gravitational constant and has the value g equals 6.67 into 10 raised to the power minus 11 Newton meter square per kilogram square. Now let's see few important features or properties of gravitational forces. Gravitational forces are universal attractive forces. That is, they exist between microscopic as well as macroscopic objects irrespective of their size, shape, separation, and intervening medium. These forces are never repulsive. These are the weakest forces in nature. They operate over very long distances, especially when the bodies are massive. For example, rotation of Earth around the Sun is due to gravitational pull of Sun on Earth. Gravitational forces obey inverse square law, that is, they vary inversely as the square of the distance between the two bodies. Gravitational forces are central forces, that is, they act along the line joining the centers of two bodies. Gravitational forces are conservative forces. The field particle of gravitational forces is called graviton. The concept of exchange of field particle between two bodies explains how the two bodies interact from a distance. Now let's discuss about the second fundamental force, that is, weak nuclear forces. The weak nuclear forces are the forces of interaction between elementary particles of short light times. These forces were discovered during the study of the phenomena of beta decay in radioactivity. In beta decay, electrons are emitted from a radioactive nucleus. It was believed that beta decay occurs when a neutron in the nucleus is converted into a proton and a neutron. The energy of electrons emitted from a radioactive nucleus varies continuously from 0 to a certain maximum value. To account for the variable beta ray energy, Pauli in 1930 postulated the existence of an uncharged particle called antineutrino, which is emitted along with the beta particle. Now let's see few important properties of weak nuclear forces. The weak nuclear forces are 10 raised to the power 25 times stronger than the gravitational forces. The weak nuclear forces exist between leptons and leptons, leptons and mesons, etc. Now let's discuss about the third fundamental force, that is electromagnetic forces. When the charges are at rest, the forces are called electrostatic forces. The forces between unlike charges are attractive and the forces between like charges are repulsive. These forces are governed by Coulomb's law. Since we know that matter consists of elementary particles like neutrons, electrons and protons, the electrons and protons are charged. As electromagnetic force is much stronger than the gravitational force, it dominates all phenomena on atomic and molecular scales. The structure of atoms and molecules, the dynamics of chemical reactions, etc. are governed by electromagnetic forces. Some of them are: forces between two surfaces in contact, force of friction, tension in a spring or rope, forces due to spring, etc., are also explained in terms of electromagnetic forces. Now let's see few important features of electromagnetic forces. These forces may be attractive or repulsive. These forces are governed by Coulomb's law, which are similar in Newton's law of gravitation. They obey inverse square law. Electrostatic forces between two protons are 10 raised to the power 36 times stronger than gravitational forces between them for any fixed distance. They operate over distances which are not very large. They are central forces. They are also conservative forces. Now let's discuss about the last and the fourth fundamental force, that is, strong nuclear forces. The forces that bind the neutrons and protons together in a nucleus are called the strong nuclear forces. They act between two protons or two neutrons, or a proton and neutron, but only if the particles are very close together. When two electrons are within 1 Fermi, that is 10 raised to the power minus 15 meter of each other, the strong nuclear attractive forces is about 10 times stronger than the repulsive electric force between two protons at this separation. A nucleus is a stable structure in spite of strong electrostatic forces of repulsion between protons. The nuclear forces have a very short range, that is, their strength decreases very rapidly with increasing separation, much more rapidly than the inverse square decrease. Now let's see few important features of nuclear forces. Nuclear forces are the strongest forces in nature. The nuclear forces have the shortest range. Nuclear forces do not depend on charge on the nucleon. Nuclear forces do not obey inverse square law. Nuclear forces are basically attractive forces. Nuclear forces are non-central forces. They are also non-conservative forces. The field particle for nuclear forces is the pi meson. The relative strengths of four types of basic forces in nature can be represented as given below.